Hey, hi, welcome to our channel Code with TD. Today we are going to see a system design question. Okay, let's go into the question. Design an integration where PhonePe connects with various banks via UPI APIs for money transfer, balance check, and mandates. So, ideally, we are going to do three things. We need to do money transfer, and we need to do balance checks, and all the mandates whenever the mandates is nothing but whenever we allow it. So after a particular time, it will detect the money from that from our account. So okay, now let's go the functional requirements. User need to check balance. Okay, user will send a request to maybe let's have it as balance or transfer or mandate to our PhonePe system, and PhonePe system should communicate with the bank API. Pay system map the request and response that comes from bank API. Response will be sent to user. So these are the functional requirements. Also we need to handle duplicate requests and yeah, all those things. So now let us assume the bank API is up and running. What else? Yeah, I think that's fine. Let's go the non-functional requirements. So first we need to think of the trade-off between the availability versus consistency over here. So our system should be highly consistent. So so maybe we could divide it like this. For initiating the transactions, in that stage high availability is needed. So whatever the transaction that comes, we could put it in a queue and process it. So as part of the transfer part, strong consistency is needed, since like the money should be debited and credited at those transactions should be should have strong consistency. Yeah, so this is the trade-off between availability versus consistency. um, so our system should be highly secure, so we need to follow all the GDPR aspects and everything. So like all the transactions, all the request response that we are doing, it should be highly secure over here. What else should we consider? So our system should be fault tolerant. I think this is fine for now. Okay, so we are going to do these things. How we are going to achieve, how we are going to communicate, which protocol are we going to use? So we will be going to use okay, so let's think. Should we go with synchronous or asynchronous communication? So ideally synchronous communication would be, we can go for the synchronous communication. So whenever the request comes to our PhonePe system, we could send it to the bank API. But the thing is, all the synchronous transactions, so we could not scale it properly. We could not scale it when there is a huge amount of requests coming from multiple users. So let's opt for asynchronous communication. So all the things that goes from our PhonePe to bank APIs. So these things we could go with the asynchronous communication, and the status update. So or the response also, it can come asynchronously, but the status updates sometimes it will take time, right? So those status updates we can send via webhooks. uh, so like if some status is pending, and like our PhonePe system like cannot repeatedly go to the bank API and poll for the status, so that will not be a right choice. So in this case, for getting the status update, we could go for webhooks. So in that case, bank API will be sending the status update to our PhonePe system. Okay, so as part of the status, there will be, we were talking about the pending status, right? So there will be multiple different status over here. Maybe let's have a diagram for that. Okay, so these will be the transaction status. Initially, whenever a user comes and gives a request in our PhonePe system, it will be initiated. Then whenever like our PhonePe system sends a request to the bank APIs, the status will be updated to executing, and then the via webhooks we will be getting updates from the bank APIs as failure, success, or pending. So this will be the transaction status over here. So now let's go with the API design. So we will be having a get request to get the balance from the user. So this will be API v1 get balance, and there can be a post transaction to do the balance transfer. So transfer money. So this could be one API, and then we could have a mandate request. So it will happen after some time, at a particular time, like whenever the end user wants, they can deduct money from the user's account. So this is mandate. Okay, what else? Yeah, I think that's it. So whatever the response that comes from the bank API, it will be coming via webhooks. So okay, now let's go with the data model. What data we'll be having ideally? We'll be having the user details. We will be having user entity, user ID, username, and all those things. And we will be having a transfer entity. So ideally we will be having user ID and from account to account, and transaction ID, which will be the primary key for every transaction. So okay, transaction ID we could have. Yeah, I think this is fine for now. Let's go with the data mapping layer. So why this is that, like we should not expose all our internal details to the like bank UPIs. So ideally what we can do is, so for okay, whenever we want to transfer, okay, amount will be there, and so what the data mapping layer could do is, in the transfer, we don't want everything. So we don't want the user ID. So this from account will have the like from this person A's UPI ID. So we don't want to send our user ID details to the system. Also whenever we are sending, like we don't want to send our transaction ID to the bank API. We don't want to expose it. So what we can do is, here we can have as a internal transaction ID, and we could map this internal transaction ID to the transaction ID. So we will be we will be doing the data abstraction. Yeah. Okay, now let's go with database choice. Which database are we going to use here? So like we want high consistency, right? So for the high consistency, if we first let's check with relational versus non-relational databases. When we consider this, like for consistency, relational database will have asset properties implemented by default inside it, so that like strong consistency guarantee will be achieved. So because of that, we can go with the relational database over here. Okay, there are multiple different relational databases, right? Like MySQL, PostgreSQL, PostgreSQL, and all those things. So for simplicity, MySQL, for the, like here we will be having some simple queries. We won't be having some complex queries and all. So MySQL will be a right fit for simple queries and all those things. So we can go with this. Okay, while we are sending the data, okay, before that, which authentication are we going to use? We need to think of this actually. There are multiple different authentication mechanisms, as I discussed in my last video. So there is authentication mechanisms like OAuth 2.0 versus mTLS versus HMAC and all those things. So when end user is involved, so if we want to give a access token or something, in that case OAuth will be a right fit. Also, then if we see mTLS, it is a mutual transaction security layer. So it will be like we will be sending a SSL certificate from our end, and the bank API will have a SSL certificate in its end, but it will be kind of a overhead, since we want to have all those certificates, and so it will be kind of overhead. So let's go with the HMAC, which is a hash based message authentication system. What we will be doing here is, whenever we are sending a JSON request, we will be adding a signature in the header. So this signature will be having a shared secret. So this shared secret will be given by the bank API. So both our PhonePe system and the bank API will be having this shared secret. Also, we will be like having the JSON payload, I mean hash of the JSON payload. So all these, by using all these things, we will be doing some AES encryption, and then a signature will be generated. So this signature will be added in a header, and we will be sending it to the bank API, and the bank API will be verifying the signature, and only then it will allow. So so similarly, the response from the bank API, we will be verifying the signature, and then we will allow the response. Okay, as part of encryption, even the JSON payload, what we can do is we can encrypt all the data using AES encryption or SHA encryption, which is a secure hashing algorithm, or advanced encryption standard. We could use any encryption mechanisms to encrypt it. Okay, now let's go with the high level design. Okay, so the diagram looks like this now. Let's go through the flow. A user will be sending a request on balance or a transaction request, and it will go to the load balancer, and it will do auto scaling and all those things. This API gateway will take care of user authentication and all those things, user authentication, rate limiting and all those things, and it will direct the a particular API request, it will direct to the particular service. So whenever a new user comes, it will go to the user service, and if the user initiates a balance, it will go to the balance service, or transaction, it will go to the transaction service. Okay, let's think it goes to the transaction service at first, and then it will go to the UPI integration layer, and over here the data normalization will be done. So we were talking about mapping the internal transaction ID with the transaction ID, right? So all those things, and data masking, and hash based message authentication, all those things will be done over here in the UPI integration. Okay, maybe we can have it as a UPI integration service. It will once we do all these things, like we can put it in a message queue, and it will be sent to the bank APIs. So all the response that comes from the bank APIs, so it will be coming to the message queue, and same data normalization will be happening in the response, and like here we will be again mapping the transaction ID to the internal transaction ID, and it will be sent to the transaction service. So here once it is done, okay, so what will be happening is, maybe if it is a pending transaction, and it will be put it over here. So in the web, via webhooks, the bank API will be putting the response status over here, and once the like if it is completed, a notification is sent to the user via the notification service. So we need to store all the transactions that we do over here. So we will be putting it in a cache, and we will be storing it in a DB. So whenever like a balance request comes, within few seconds, if the user clicks for a balance service, so like within microseconds if it is coming, we can show it from the cache. Also, if the user wants to see the recent transaction, we can show it from the cache. Okay, so here in our system, correctness is very crucial. Correctness plays a crucial part. So how we can ensure the correctness? So what we can do is, a bank API can send all the logs, maybe like every day it can send the logs. So what we can do is, we can have a reconciliation service which will like verify whatever the transaction done over here, and whatever the logs that are coming from the bank APIs. So based on this, we can do a reconciliation and figure out if there is any mismatch. We can fetch from this DB and verify. So this reconciliation service will ensure the correctness, and if there is any mismatch over there, we can classify it. If it is a if we can fix this mismatch automatically, we can trigger it, or else we can like manually the finance team can verify, and they can handle it. So these things will be happening over here. Okay, now let us okay, now we need to think, if there is something, if something goes wrong, like what we need to do. So if something goes wrong in between, we need to do some compensating transactions. So here for this payment system, we can go with the microservice architecture, and we can use the Saga pattern. So this Saga pattern, what will be happening is, so all the transactions will be happening. So whenever so all the transaction will be happening, whenever something goes wrong in between, it will do compensating transactions, which is a rollback. So rollback, so that finally the end state will be it should be compensated. It should not be in a middle state, and it should not fail. So this Saga pattern will be a right fit over here. Okay, in the Saga pattern, ideally we can two things will be there: choreography and orchestration. So here we can maybe we could go the orchestration. Maybe we could have one orchestrator service, uh, and if something goes wrong, the orchestrator service could handle all the compensating transactions. Okay, now we need to think of failover scenarios. So maybe what if there is a huge amount of requests sent to the bank API, and what if huge amount of response comes from the bank APIs. So all these things, like since we are going with the asynchronous communication, we could handle it. And so if there is something like if something goes wrong, so we could, like if there, what if there is a response delay, so we could have a timeout, and we could do a retry after some time. So there are different kinds of retry mechanisms, such as exponential back off, incremental back off, fixed interval. So we can go with the right retry, and maybe we could put it in a retry queue, and we could process it. So if like after some maybe if we are taking as a retry count as 3, and after 3 times, after trying also, if the request is failing, then we can put it in a dead letter queue, and someone can verify over that. Okay, so we need to go with the graceful degradation. So whenever if something goes wrong, maybe we could show a proper response to the user, like this bank API is down, maybe like that. Also if like we are continuously calling the bank API, and this bank API is down for a long period of time, then we can go with the circuit, implement the circuit breaker mechanism, and the circuit will be open for some time, and it will go to the half open state and closed state. So these things will be happening. Okay, what else we need to think of? We need to think of what if there is a duplicate request. So that plays a crucial part. So this duplicate request we could handle with ideally we could have a idempotency keys, that will be the transaction ID. So whenever whenever we are retrying those transaction IDs, since it is unique, and we are showing it as a primary key in our database, so even the bank API will be using it, so that it will not allow duplicate transaction. So what if there is okay if like everything, we could not assume the bank API is right for every time, since that is an external service. So we need to check it from our side to ensure the correctness, so that we are having a reconciliation service, and we are doing this. Okay, how we are going to scale? So as part of scaling, we could have multiple instances of load balancer and all the services, so that if one service goes down, other instance can pick up and like start, it could take up and work on it. Also, if there is one cache, it will be a single point of failure. We could have multiple MQs. Yeah, we could have like this. Even reconciliation service also, we could have multiple instances. Since all these services will be stateless service, it is easy to scale it. So as part of database, we need to have multiple replicas, since one instance cannot handle a lot of load. So we can have multiple replicas of database, and we need to shard it. Basically we can shard it using the user ID. That will be a sharding key, and that will be a good sharding key, so that we could divide properly. Okay, now we need to think of very important part. So what if like we need to think of the delivery semantics for this message queue. So for other there are different delivery semantics, like at least once, at most once, and exactly once. So for a transaction system, exactly once delivery semantics is very important. It is difficult to implement the exactly once delivery system, but that will be a right fit and we need to go opt for it. So exactly once is nothing but we need to have both at least once and at most once. So this at least once we could do this by having doing the retries and all, and at most once we can handle it using the idempotency keys. So this is how we could achieve the exactly once delivery semantics, which is very important in our entire transaction. Yeah, so this is how our system will look like. Yeah, thank you for watching. Please subscribe to our channel. Bye.